Okay, so now we're going to go over, having introduced power series in 11.8, now we're going to talk about representation of functions as a power series. Section 11.9, representation of functions as power series. Eventually, we'll be using integration to integrate functions whose antiderivatives are easy to find. Using power series, it's really amazing, like integral of e to the x squared, which we couldn't integrate using traditional methods, but we could actually write it as a power series and then integrate. So let's recall what we know about the geometric series. The geometric series, so if you have 1 plus r plus square plus r cubed and so on, which is sigma a r to the n over from n equals 0 to infinity. So this is a plus ar squared plus ar cubed. So the first term is a and the common ratio is r, so this equals a over 1 minus r. Okay. Now if we let a equals 1 and the common ratio r is x, then a power series centered at 0 representation for 1 over 1 minus x instead of 1 over 1 minus r, so it's 1 over 1 minus x, and we're going to call this f of x. So it would be 1 plus x squared plus x cubed and so on, which is sum x to the n equals 0 to infinity. So you can see we can represent this function by this power series, okay? And this is true, of course, if absolute value of x is less than 1. That's when the series converges. So if we want to represent f in another interval, then we have to construct a different power series. For instance, to obtain power series, instead of centered at 0, it's centered at -1. This is what you would do. So instead of 1 over 1 minus x, you want to use centered at -1, so you want there x plus 1. So we're going to write this as 1 minus x plus 1 minus 1, which would be 1 over 1 plus 1 is 2 minus, so we add these and when we group these together. So you can do that this is centered at -1, but we want to get rid of this 2 because it has to be 1 over, it has to look like that. So 1 over, if we factor out the 2, then it would be 1 minus x plus 1 over 2, which is going to be written as 1/2 over 1 minus x plus 1 over 2. So in this case, a is 1/2 and then r is x plus 1 over 2. Okay, so absolute value of x plus 1 over 2 should be less than 1. X plus 1 is less than 2, so x plus 1 is between -2 and 2. So x is between 3 and 1. Okay, and so we can write 1 over 1 minus x. As you can see, it would be, you pull the 1/2 out, and then it's gonna be 1 plus x plus 1 over 2 plus x plus 1 over 2 square, and so on, which we can write as sum from n equals 0 to infinity 1/2 x plus 1 over 2 to the n if x is between -3 and 1. So we need the same function. Instead of power series centered at 0, we wrote it in terms of a power series centered at -1 and different interval of convergence. Alright, so here's another example. Represent the given function by a power series. The first one is f of x equals 1 over 1 plus x. So we have keep in mind, this is 1 plus x squared plus x cubed plus so on, which is sum x to the n equals 0 to infinity. So to use this model, we write 1 over 1 plus x as 1 over 1 minus negative x. And we put a negative x in there, so it's 1 plus negative x squared plus negative x cubed plus negative x to the 4 plus negative x to the n, and so on, which would be 1 minus x plus x squared minus x cubed plus x to the 4, and so on, which is sum n equals 0 to infinity. Instead of x to the n, it's negative x to the n, which is negative 1 to the n, x to the n. Again, absolute value of x is less than 1. And you could actually do this using long division. Okay, using long division. 1 over 1 plus x. You do 1 over 1 plus x. So 1 divided by 1 is 1. 1 times 1 is 1. 1 times x is x. Then you change the signs. So you get negative x. So negative x divided by 1 is negative x. Negative x times 1 is negative x. Negative x times x is negative x squared. Switch the signs. X squared over 1 is x squared. X squared times 1 is x squared. X squared times x is x cubed. You switch the signs, and so on. You keep going. Okay? As simple as that. You can actually get the power series that represents the function 1 over 1 plus x by dividing using long division 1 over 1 plus x. If you remember long division. Okay? Here's another example. How do we find a power series representation for 3 over 2x minus 1, but it has to be centered at 2. Okay, it has to be centered at 2. So we need x minus 2 in there. So we're going to have to work this out. So 2x minus 1, 3 over, so we need a 4 to have x minus 2, right? And we have 2x, we need 2 times x minus 2, so we need 2x minus 4, so we minus 4 and then add 4. So I subtracted 4, get that, and then added 4 to balance it out, and then brought the minus 1 down. So this is 3 over 2 times x minus 2 plus 3, which we can write as 3 over 3, and then factor out the 3, so it will be 1 plus 2/3 x minus 2, which would be 1 over, remember we got to match it with 1 over 1 minus x, so 1 over 1 minus negative 2/3 x minus 2. Okay, so it will be 1 plus negative 2/3 x minus 2 plus negative 2/3 x minus 2 squared plus negative 2/3 x minus 2 cubed plus negative 2/3 x minus 2 to the n, and then goes on. and all this has to be less than 1. That's a geometric series. The radius has to be less than 1 for it to converge. So that means half seed value of x minus 2 is less than 3 halves. X minus 2 is between negative 3 halves and 3 halves. Add the 2's. Negative, that's 1 half is less than x is less than 7 halves. And if you want to write it as a series, n equals 0 to infinity, negative 2/3 x minus 2 to the n. Alright, now can we do some operations with power series like we do with summation notation? Let's see. Operations with power series. So let f of x be represented by a power series, sigma n equals 0 to infinity a n x n. Same with gx, sigma n equals 0 to infinity b n x n. So two functions represented by two different power series. F of kx, if you want to put kx in there, then the kx has to be in there. So sigma an kn x to the n equal to infinity. You put a kx to the power n, and it's going to give you this. And f of x to the m, it's the same thing, n equals 0 to infinity a n x to the m to the n, which is sigma n equals 0 to infinity a to the n x to the m n, power to power rule for exponents. And if you have f of x plus g of x, you're adding the series a n x n plus sigma b n x n, which is sigma a n plus b n factor out x n. Same thing with subtraction. And you know, every power series has an interval of convergence. The new function is represented by a new power series. This has an interval of convergence, which is at the intersection of interval for f and g. So you're going to see where they overlap. Okay, you're going to see where the intervals of convergence overlap. And here's an example. Express the functions, express the function as a sum of power series by first using partial fractions. Remember partial fractions? I just tested you on that. Find the interval of convergence. And the function that we're looking at is 4x minus 7 over 2x squared plus 3x minus 2. So first, you want to express the function as sum of power series, because remember we only have this, so we can't use a power series if it's not similar to that, okay, or can be not like that. So we're going to break down the bottom. Luckily it does break down. It's 2x minus 1, or actually x plus 2 times 2x minus 1, factoring it, and we write it as using partial fractions, a over x plus 2 plus b over 2x minus 1, and then multiply by the LCD by x plus 2 2x minus 1. So we get 4x minus 7 is a times 2x minus 1 plus b times x plus 2. So 2ax minus a plus bx plus 2b. We group the x terms together, so 2a plus b, factor out x, and then minus a plus 2b 4x minus 7. So the x terms equal the x terms. So 2a plus b equals 4. The constant equals the constant. So an easy system of two equations to solve. Should be easily solve it. So you get that. Now we got our original function is broken down into two functions whose power series are easier to get. Minus 2 over 2x minus 1. So if you look at 3 over x plus 2, you can write this as 3 over 2 times 1 plus x over 2, which is 3 over 2, 1 plus x over 2. So 3 over 2, 1 plus x over 2 is 3 over 2. 1 over 1 plus x, so it's 1, so it's 1 minus negative x over 2, so 1 plus negative x over 2 plus negative x over 2 squared plus negative x over 2 cubed, and so on. You can write as sum from equals 0 to infinity, 3 over 2 negative over 2 to the n. As for the second one, 2 over 2x minus 1. You're gonna write this as, you're gonna times by a negative to flip it. So you get negative 2 over 1 minus 2x, which would be negative 2, 1 over 1 minus 2x. So it'd be negative 2 and then 1 plus 2x plus x squared plus 2x cubed and so on, which is sum n equals 0 to infinity, negative 2, 2x to the n. Now you have a minus there, so you're going to get a plus, so this would be, so f of x would be written as the sum of these two, which is sum n equals 0 to infinity, 3 over 2, negative x over 2 to the n, plus sum from n equals 0 to infinity to 2x to the n. We can combine them like I did. You can see how I combined them. Now the interval of convergence, this is an absolute value of negative x over 2 is 1, and they have to overlap. Absolute value of 2x is less than 1. This is absolute value of x is less than 2, and absolute value of x is less than 1/2. So where they overlap, it's this interval. That's where they overlap. Okay. Now to differentiation and integration of power series. Differentiation and integration of power series. Let's look at differentiation, term by term differentiation. If f of x equals the general power series Cn x minus a to the n, which equals C0 plus C1 x minus a plus C2x minus a squared plus Cn x minus a to the n plus, which converges for absolute value of x minus a is less than r, then the series f prime of x which equals sum from 1 to infinity n Cn x minus a to the n minus 1. Again, you take this, times it by Cn, and then minus 1 from the power, and then times the derivative of x minus a, which is 1, the power rule. Why is it n equal 1? Because remember, the first term is a constant, its derivative is 0. So n equals 0 doesn't, if you put a 0 for n here, it's going to give you 0. 0 times whatever is 0. Okay, that's why we start at 1. Okay, and this is going to be C1 plus 2c2 x minus a plus 3c3 x minus a squared plus n cn x minus a n minus 1 and so on. Okay, so you differentiate the series term by term and it converges, same as that, converges for same as the original one. And if the series for f converges for all x, then this also converges for all x. So same interval of convergence. Now integration. Term by term integration. Term by term integration. Sorry, let me mute this. The integral of f of x dx is going to be, again, you're going to integrate. Remember, f of x is sum n equals 0 to infinity cn x minus a to the n. So what you're going to do, you're going to add 1 to the power and then divide by the new power. So it's going to be sum 0 to infinity cn x minus a n plus 1 over n plus 1, which would be a constant. You're going to add a constant when you integrate, plus when n is 0, it's c0 x minus a, c1 x minus a squared, just anything over 2, c2 x minus a cubed over 3, cn x minus a n plus 1 over n plus 1. And then we add c in the front because this is indefinite, so we want to be able to see the constant. Remember, when we do antiderivative, we have infinite solutions. And again, it converts for absolute value of x minus a. Okay, the only thing is when you integrate or differentiate at the endpoints at less or equal to r, that may or may not conform with the original function. Okay, but everything else does. So find power series representation for f of x equals 2 over x plus 1 cube using derivatives. Okay. Well, we know a representation for 1 over 1 plus x, right? If you find its derivative, what derivative of 1 over 1 plus x? It's the derivative of 1 plus x to the negative 1, which is negative 1 plus x to the negative 2. But we need a cube, so let's find the second derivative of 1 over 1 plus x, which is the derivative of the derivative. And that's going to be 2, 1 plus x to the negative 3, which is 2 over 1 plus x cubed. Perfect. That gives me that function. So if we take the power series for 1 over 1 plus x differentiated twice, it's going to give me a power series for this one, okay, using derivatives. That's what this is about. So let's do that. So let's start with 1 over 1 plus x, which is 1 over 1 minus negative x, which is 1 minus x plus x squared minus x cubed plus x4 minus x5, which equals sigma n equals 0 to infinity negative 1 to the n x to the n. That means if you find the derivative, it's going to give you negative 1 plus 2x minus 3x squared plus 4x cubed minus 5x4 blah blah, which is sigma n equals 1 to infinity, negative 1 to n, x to the n minus 1. Right? And remember, we start at 1 because the constant is 0, so n equals 0 doesn't exist anymore. And then the derivative, again, the derivative of this, 2 over 1 plus x cubed, that's going to equal 2 minus 6x plus 12x squared minus 20x cubed, blah, 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 which is the derivative of, again, we're gonna eliminate that, so it's gonna be n equals 2 to infinity, n negative 1 to the n minus 1, x to the n minus 2. And absolute value of x is less than 1, same as the original one. Now, so we saw one using derivative, now let's see one using integration. Find power series representation for f of x equals ln of 1 minus x squared using integration, and also give the radius of convergence. Alright, so let's solve this. We know that ln of 1 minus x squared is ln of 1 minus x plus ln of 1 plus x. We also know that the integral of 1 over 1 minus x dx equals negative ln of 1 if x, if the domain is right, so we don't need absolute value. And the integral of 1 over 1 plus x dx is ln 1 plus x. So we're going to times this by a negative to get that. So we have this series, we integrate to get those functions. So 1 over 1 plus x, which is equal to 1 minus x plus x squared. So x cubed plus x4 minus x5, blah, 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 which is sigma n equals 0 to infinity, negative 1 to the n x to the n. That means the integral of 1 over 1 plus x dx equals the integral of all this, which is x, minus x squared over 2, x cubed over 3, x4 over 4, x5 over 5, minus x6 over 6, which equals plus constant, don't forget, plus c, which equals sum from n equals 0 to infinity. We're going to add 1 to the power, so it would be x to the n plus 1 over n plus 1 plus c. Okay, now let's look at 1 over 1 minus x, and then we're going to get the integral for that. So, and since 1 over 1 minus x is 1 plus x squared plus x cubed plus x4, blah blah blah, which is sum xn n equals 0 to infinity. That means the integral of 1 over 1 minus x dx is integral of 1 plus integral of x plus integral of x squared. That's x4 over 4, x5 over 5, which is going to plus c, which is going to be sum from 0 to infinity x to the n plus 1 over n plus 1 plus c. But f of x equals ln of 1 minus x plus ln of 1 plus x, which is going to equal, so for ln of 1 minus x, it's going to be negative this, okay? And I don't know, so let me do plus minus, so ln of 1 plus x, it's there, so let's write it down, sigma equals 0 to infinity, negative 1 to the n, x to the n plus 1 over n plus 1, plus ln of 1 minus x, which is going to be minus that because of the negative, n equals 0 to infinity, xn plus 1 over n plus 1, plus, let's call it c2, which is, the sum of these two constants. So we can put it together, n equals 0 to infinity, negative 1 to the n, minus 1 over n plus 1, x to the n plus 1, plus c2, which also can be written as, you can work it out and see that, negative, because it will be, once they're going to be 0, and another time they're going to be negative 1. So negative 1 x to the 2n plus 2 over n plus 1 plus c2. To find the extent, we always let x equal 0. So ln of 1 minus 0 equals c2, that means c2 equals 0, so we don't really need c2. And absolute value of x is less than 1 from both cases. Alright, one more and then we're done with 11.9. Use integration to find power series representation. Use integration to find power series representation for f of x equals tangent inverse of 2x. Again, we're going to use integration, give interval of convergence. Alright, so we want to use integration to find power series representation for f of x equals tangent inverse of 2x. So I want to find a function whose integral is going to give me tangent inverse of 2x, and it's going to be something we could have a power series for, and it's this one, 1 over 1. 1 plus x squared will give me tangent x. If I do 2x squared, it would be tangent inverse of 2x, but then we're going to have a constant there, plus c. Because the derivative of tangent inverse 2x is 1 over 1 plus tangent 2x squared in parentheses times 2, so that's what the 1/2 is for. So this means tangent inverse of 2x is 2 integral of 1 over 1 plus 2x squared dx. Okay, so we can do a power series for this, integrate and times by 2 to get that. Okay, so 1 over 1 plus 2x squared can be written as 1 over 1 minus negative 2x squared, which would be 1 plus negative 2x squared, negative 2x square plus negative 2x squared cube, 1 plus x squared x cube, and so on, which is sum from n equals 0 to infinity of negative 2x squared to the n, or you can write as 0 to infinity negative 1 to the n, 4 to the n, because 2 to the second is 4, 4 to the n, and then x to the 2n. Okay, so that's that. So now the tangent inverse of 2x is 2 times the integral of 1 over 1 plus 2x squared, which is 2 times the series, the 1 to the n, 4 to the n, x to the 2n, over 2n plus 1, plus c, of course, where absolute value of 2x is less than 1, which means absolute x is less than 1/2, and letting x equal 0, wait, I gotta integrate that, I did not. So this, it would be 2n plus 1 here. I forgot to put 2n plus 1 over 2n plus 1, okay? Because we have to integrate term by term. Letting x equal 0, that means tangent inverse of 0 equal 0 plus c, so c equals 0, and that's it, the constant is 0. And that will do it for 11.9. I'll see you soon in 11.10.